Hi there. Welcome back to this tutorial series where we're building a Sokoban game in Unity. In the previous episodes, we set up the project, added smooth player movement on a grid. We have also implemented pushable boxes. In this episode, we will be adding walls and goals so we know where the player can move and where to push the boxes. We'll start with the walls. Walls are essentially just boxes, but unlike the pushable boxes, they can't be moved. Let's set them up in the scene. First, I'll remove the last two boxes we added. Don't worry, we can easily add them back later since we have prefabs for these. Next, we'll duplicate the remaining box in the scene and unpack the prefab to unlink it from the original prefab. After that, rename it to something like wall and reposition it in the scene so we can clearly see it. Finally, we'll create a new material for the wall, just like we did for the previous objects, to give it a distinct appearance and make it easy to identify in the scene. Once you've chosen a color you like, assign the new material to the wall object in the scene. Next, change the tag for the wall to untagged and remove the box controller script from the wall, as it doesn't need any movement logic. The wall object is now ready to be used, but before we do anything else, let's create a prefab of the wall. This will allow us to easily reuse it later in the scene or in other levels. To create the prefab, simply drag the wall object from the hierarchy into the prefabs folder, just like we did with the box object earlier. The wall has the blocking layer, just like the box, which ensures that it will stop the player and any boxes from passing through. We can also remove the rigid body component from the wall, as it doesn't need any physics-based interactions. That's it, let's test drive it. Alright, it works as expected. The player can't pass through the wall, and the wall can't be pushed. Additionally, boxes can't be pushed through the wall either. Everything is working perfectly, so we're happy with that. Now it's time to create a level. Let's start designing the layout for our first level by placing walls and boxes in the scene. You can add new wall prefabs to the scene and scale them to create your level, or simply duplicate the current wall to create new walls. I'll begin by scaling the wall and duplicating it to build out my level. Feel free to rotate and scale the walls as needed until you're happy with your level layout. When designing your level, remember to use whole integer values when scaling and positioning your objects in the scene. Since this is a grid-based game, keeping everything aligned to the grid will help ensure smooth and consistent movement, avoiding any unexpected misalignments of objects. I am happy with this level. We will adjust it later if needed. Let's change the camera angle to get a better view of the playfield. Adjust the camera's position and rotation until you have a clear and nice perspective of the entire level. Let's test the game again to see that everything works as expected. Every angle is covered, and the walls are stopping us from moving out of the level. As you may have noticed, my object snapped perfectly to the grid when I designed the level, and that's because I held the control key on the keyboard while moving the object. I've also set the grid snapping in the editor to 1 unit, which works perfectly since I'm working with a grid-based game. If I change it to 0.25, the objects will move by 0.25 units on the grid while holding the control on the keyboard. I'll change it back to 1 unit for now to keep things aligned. I'll add a few more boxes to my level. You can either duplicate the current box in the scene or drag in a box prefab. Now, it's time to create the goals for our boxes. These are indicators in the level that show where the boxes must be placed to complete the level. Start by dragging a wall prefab into the scene and rename it to goal, then unpack it to unlink it from the original prefab. Change its collider to be a trigger so we can detect when a box is placed on the goal without causing any physical interactions or collisions. Position it in your level and adjust the size to make it look like a pressure plate. Next, create a material for the goal and assign it to the goal object, giving it a distinct color. Once that's done, drag the goal object into the prefabs folder to create a prefab. You can now create as many goal objects as there are boxes and place them wherever you like in your level. I think scaling the goal on the edges will make it look more visually appealing. Looks like I forgot to remove the layer from the goal object, so let's do that now. Otherwise, we won't be able to push boxes onto them if they have the blocking layers set. That's it for the goal object. We don't need to do anything more for it. Now, we need to write some code for the box object to detect when a box is placed on a goal. Start by opening the box controller script. Let's add a public bool field called onGoal. This will track whether the box is currently on a goal. Next, we'll create two private methods, onTriggerEnter and onTriggerExit. These will handle detecting when the box enters or exits a goal area. In the onTriggerEnter method, we detect when the box collides with another collider. We check if the object the box collided with has the goal tag. If it does, we set the onGoal variable to true, which means the box is now placed on a goal. In onTriggerExit, the logic is similar, but this time it's triggered when the box leaves the goal. When the box exits the goal area, we can reset the onGoal variable to false, indicating that the box is no longer on the goal. Let's save the script and test it in the editor. Before we can test it, we need to create a new tag called goal and assign it to the goal prefab. This will ensure that all instances of the prefab automatically get the goal tag, so we don't have to assign it manually on each object in the scene. Create a new tag and name it goal. Select the prefab and choose the tag called goal. Now let's test the game to see if the box correctly detects when it enters and exits the goal area. If everything works as expected, the onGoal variable should change when the box interacts with a goal. Looks like it's working just fine. That's it for this episode. In this episode, we added walls and goals to our Sokoban game, enabling boxes to be placed on designated goal areas. We also implemented the logic to detect when a box enters or exits the goal, which is crucial for completing levels. In the next episode, we'll introduce a game manager and add logic to detect when all boxes are placed in the correct positions, allowing us to complete the level and show the user that the level is finished. I hope you enjoyed this episode and learned something new. Don't forget to like and subscribe, and also hit the notification bell so you don't miss the next one.